use the slope-intercept form to graph the equation. We're given an equation y equals -1/2 x plus 5. This equation actually is given to us in slope-intercept form already. Let's compare it to what slope-intercept form is. Positive 1y equals mx plus b. In other words, the y is already solved. This equation is solved for y, so that when we look at the coefficient of x, it tells us what the slope of the line is. M stands for slope in this equation, in this form of an equation, and b stands for the slope-intercept, the y-intercept of the line. So here's how we use b. B is known as the y-coordinate of the y-intercept of a line when the equation is written in slope-intercept form. So whatever we've determined the value in the b position, we replace b with it in this ordered pair. Of course, the first number in an ordered pair is an x value or x coordinate, and the second number in an ordered pair, it represents a y value or a y coordinate. So when we go over to our graphing area, we can actually graph the y-intercept very easily. X is 0 in the y-intercept, which means we don't move left or right at all. But y is 5, y is positive, we move up 1, 2, 3, 4, 5, and we're able to mark a point on the y-axis at 5. So there is one point on our line. It's the y-intercept. Now, the other issue that we need here is we need to use the slope to generate a second point. After all, we only need 2 points to draw a straight line. So we have identified the slope of this line as -1/2. We want to be able to use rise over run, the geometric definition of slope. We want to be able to use it. Rise over run. This is one of the versions of what slope is interpreted to be. But the problem is, if we tried to circle rise and run, we're missing the negative sign information. It's not when it's in line with the fraction bar, to the left of the fraction bar, it's not being captured with either the numerator or the denominator. So what we need to do is transform a negative fraction into a fraction that has a negative numerator and a positive denominator, or a fraction that has a positive numerator and a negative denominator. Then we're able to clearly identify the negative information either with the rise. Look, when we circle rise now, the negative sign is clearly included in the rise, and the run would be +2. If we were to put the negative in the denominator, then we can clearly, when we label rise and run, we have a positive numerator and a negative denominator. We clearly are including the negative sign as part of the consideration of correctly moving the slope to graph the line correctly from this equation. So here's the idea. When we rise negative, we move down from some point that's on the line. When we run positive, we run to the right. When we, and let me switch colors so we can see, because we're going to graph both of these and make sure that we understand you can't make a mistake with either one of these. When we run positive, when we rise positive, we move up. When we use this red slope. When we run negative, we're going to move left. So let's graph both of these slopes. Let's use this light purple slope first and do these two moves. We're going to move from a point that what's really important is we don't move the slope from the origin. We have to move the slope that's given from the equation. We have to move the slope from a point that we already know. That's why it was very important to graph this y-intercept as the first step. Now, as a second step, we're graphing the slope information to generate a second point. And of course, we're going to get a third point as well here with the red one. So if with the purple slope, we're going to rise -1. Rise -1 means move down 1. Then run +2. So we're going to mark that point. I'm just using the background grid to go down 1 and right 2 dots. And that's the proper way to use these, the grids when they're given to you, the way they are in this problem. Now let's go graph a point using this red slope. I'm going to rise 1 and then move 2 to the left. From our y-intercept, we're going to rise 1 and move 2 to the left and mark a point. Now, we mark this point. Don't those 3 colored dots look like they would graph as a line? And they do. Let me see if I can draw a nice straight line here through these points. So what we're looking for if we were to look for the answer in a multiple choice set of answers, we're looking for a line that crosses the background grid and the y-axis. Here's the background grid points and the y-axis. Let's see, what do we use? We used blue for the y-intercept. But in particular also, we're looking for one that crosses. The easiest point to find is the one that crosses the y-axis at 5. Then we're looking for the grids on multiple choice answers that would satisfy the correct slope in this fashion.